Okay, hello everybody. We're going to start doing 10.5 absolute convergence, the ratio and root tests here. So first let's start off with what absolute convergence is. So let's start with this one here. You should recognize this kind of a series, and we can do this one. I'm going to leave it to you to double check this, but you'll end up getting 1 minus negative 1/4. You should be to the point where you can do that one pretty simply now, which is just going to be 5 over 5/4, which is just 4, so that one converges. Now if we look at this one, at the second one, this one diverges. So I maybe shouldn't put an equal sign, but diverges, and that's because that negative 5/4, the magnitude of it is greater than 1, unlike in the first one. And then this third one, we've added this absolute value here, right? So how are we going to go about handling that? Well, here we're going to have a sum, n equals 0 to infinity. We don't have to keep that 5 inside the absolute value because it's going to have no effect on it whatsoever. So it's the absolute value of negative 1/4 to the n. And basically, depending upon what is, that's going to either be a positive number or a negative number, but no matter what, it's going to end up being a positive number because we're taking the absolute value of it. And so n equals 0 to infinity gives us 5 times 1/4 to the n, which is just going to be, well, when we have that 1/4 to the n, we're going to get 5 times 1 over 1 minus 1/4, just like we did in the first one there, except with a positive 1/4, which is going to be 1 minus 1/4 is 3/4, so this becomes 5 times 4/3, the reciprocal, and then that's just going to equal 20 over 30, oops, not over 30, 20 over 3, and it converges. And I wrote converges very poorly, but it converges. All right, and so let's take a look at a definition here. A series, sum over an, converges absolutely, in other words, is absolutely convergent if the corresponding series of absolute values converges. All right, that's how we're going to check for absolute convergence. And so the absolute convergence test is basically saying if our sum of all the absolute values converges, then an converges. Oh no, this was 1. N equals 1 to infinity. Okay? And so absolute convergence means you have regular convergence of it without the absolute values. So let's try taking a look at one of these. So let's look at this. Use the absolute convergence test to show that the following series converge. And so we want to look at our sum, but this time we want the absolute value of what's there. Okay? And then what happens is this little part right here, well, it's just going to give us plus or minus, plus or minus, plus or minus, and then we're taking the absolute value. So essentially, this is just going to be the sum of 1 over n squared. Okay? And so it's a p-series with p being p equaling 2, which is, it's greater than 1, right? And so it converges. And therefore, it converges, the original one converges absolutely. Okay? Let's take a look at our next one. Here we have sine of n over n, and we're going to look at our sum, n equals 1 to infinity, of the absolute value of sine of n over n squared. This one is going to look like sine of 1 over 1 squared absolute value plus sine of 2 over 2 squared absolute values plus so on and so forth. And so if we look at that, remember the sine values are always going to be 1 or less. Therefore, what we can say is that the sine of n over n squared is always less than or equal to 1 over n squared, right? Because all your sine values all end up between, well, really between -1 and 1, but then we're taking the absolute value. So they're all between 0 and 1, which means our numerator is always going to be less than or equal to this numerator, which means it's always going to be less than or equal to that. And since we know that 1 over n squared converges, then we know that our sine of n over n squared absolute value must also converge. Therefore, sine of n over n squared, this converges. Okay? And therefore, since that one converges, therefore our sine of n over n squared converges absolutely. Okay? So let's continue on. Let's take a look at some tests we can get from this. Let's look at the ratio test. This is useful for dealing with exponential and factorial sequences. So let's take a look at n plus 1 over an. For a geometric series, a r to the n, that summation, a n plus 1 over a n equals a r to the n plus 1 over a r to the n. That's just going to end up equaling r, because your a's are going to cancel and all of your r's are going to cancel except for one of them, because this might be r to the 11th and the denominator it's r to the 10th. And our summation of n equals 0 to infinity, a r to the n, is going to converge if r is less than 1.